Okay, the last video ended a bit abruptly on when we were doing October M1 International Edexcel paper. Let's get on with question 4, which is a vectors question to do with motion in a plane, constant velocity. There is a useful little formula when something's traveling with constant velocity in 2 dimensions, which is final position vector is equal to initial position vector plus velocity times time, which is exactly what we're going to use for part A. They said that they've used P for the vector at time t of the particle P. The initial position vector is this, minus 5i plus 9j. And it's traveling with this velocity. Okay, and that's it. I'm going to collect the i's and j's together just to make the next part easier, because I'm almost certainly going to be useful to collect the i's and j's together. Here's 9 minus 2j at 2tj. There we go, that's that done. Okay, part B. Part B says find a position vector P which when P is due west of A. That means they're in line in this way, due west. That means the J component is the same. But we know the J component is equal to 2, so it's equal to 2 in this case. So we just get 9 minus 2t equals 2, which gives us 2t is equal to 7, so t equals 3.5. But it didn't want the time. It wasn't just asking for the time; it was asking for the position vector of p. So the position vector of p, when t is equal to 3.5 at this time, will be equal to this when t is that will be equal to minus 1.5 I. And of course we know that this is going to have to go to come to whatever the j component was, which is 2j. Putting 3.5 in now. Okay, that's part B done. So it's doing pretty well so far. Part C, now it's talking about something that's parallel. So 2b minus 1i plus 5 minus 2bj is parallel, not equal to, but parallel to our velocity here, which is I minus 2j. So we can times this vector by anything, by some number, which will give you this. So they're in the same ratio. So whatever this times this will be the same as whatever this times this will be. So we're just using a ratio kind of argument. So if I divide the I by the j on both of them, they should be the same, because they've got to be, if they're parallel, they've got to be in the same ratio. 2b minus 1 over 5 minus 2b is equal to 1 over minus 2. So that gives me, if I multiply that out, minus 4b plus 2 is equal to 5 minus 2b, which gives me 2b equals 3, so b equals 3 over 2. Okay, so not too bad a question. That's question 4. Let's have a look at question 5. So question 5 is a statics question. Pretty common type of question. Things going at an angle here. You have to take a bit of care. It says it's in limiting equilibrium because it's talking about the coefficient of friction and it's at the point of sliding up the plane. I would mark friction down the plane. There's a reaction force here. We know that it's in limiting equilibrium, so we can mark a force of mu r down there. We've got the weight of the thing, which is 0.5 g. Let's mark on the angle 30 degrees here. So it's going to be a good idea to resolve parallel and perpendicular. Let's resolve perpendicular first. So force is going in this direction. Obviously we've got the R force, this force here. Okay. Then we've got the components of some forces. Let's look at the component of the 8 Newton force first. Okay, we're looking at components perpendicular to the plane. Let's put in a different colour for a moment. We're going to have a force here coming into the plane like that. And we're also going to have a force coming into here like that. But let's worry about this one. What I always say is, because we've marked the angle 40 degrees here, on this kind of a space here, that means the ratio is going to be sine. So that will be 8 sine 40 will be this component here. Okay, and there'll also be a component of this force, this weight force. Now this time it's marked next to this force here. So that will be equal to 0.5 g cos 30. Okay, so let's just put that into our equation. We've got R is the only force going upward. Is the only force going upwards, and then we've got this component here. So that's equal to 8 sine 40. Okay, and this component here also going in this direction, so that's plus 0.5 g cos 30. So now let's resolve parallel to the plane. Okay, we've got going up the plane, as I said before, the component, this component here, and that's going to be, because it's next to this angle here, 8 cos 40. Okay, but we've got the component of this force here, the weight, that's going down the plane, and that's 0.5 g sine 30, because it's kind of away from my angle I've marked there. Okay, so let's write that into our equation. We have 8 cos 40 going upwards. Yeah. Everything else is going downwards. The component of the weight, 0.5 g sine 30, and also the mu r. Okay, so now we can substitute for r and hopefully get our answer. So what we'll do is I'll isolate mu r. So we have mu r is equal to 8 cos 40 minus 0.5 g sine 30. And we sub for r. We have mu times 8 sine 40 plus 0.5 g cos 30 is equal to 8 cos 40 minus 0.5 g sine 30. So that's going to give us our value for mu. Mu is equal to 8 cos 40 minus 0.5 g sine 30 all over 8 sine 40 plus 0.5 g cos 30. Okay, and that should give us the answer, which is to Three significant figures, 0.391, or you can give 2 if you want, 0.39. Okay, so that is the answer for question 5. Let's look at question 6. Okay, of the 26 students I marked papers for, this was the worst done question. I don't know, maybe some people couldn't get started with it because there was lots of information and you had to set up 2 different situations. And the thing asked for the speed of B, and it was actually, I think that distracted people. It's actually easier to work the time out where they've actually both overtake each other. Because if we look at what car A has done, that travels 200 meters. No, it doesn't. It travels some distance, but it's 200 meters behind some. It's 200 meters. The instant when B is 200 meters behind. So this is A, and this is B, and this is where point where B overtakes. Here, and what's the speed here? Obviously we don't know what the distance is, but if we call it x, and we can call this one x plus 200. Yeah, so B. So the thing that's common, the thing we're given to both of them is the accelerations and the initial velocities of all of them. For A, its acceleration is 0.4, and U is equal to it is there somewhere. U is equal to 35, and for B, A is equal to 0.5 and U is equal to 44. So we've got these which are obviously fixed that we know of. We don't know the final velocities of either of those, but because we've got these two that's fixed and we've got a comparison of the distance, we know that B has moved 200 meters further. We really want an equation which links S, A and U for both of them, and we can work out the time when one overtakes the other. And once we've got the time, then we can actually work out the speed easy enough. So let's work out, let's apply S equals ut plus half at squared for A. We're going to call S x. We've got A is equal to 0.4. We've got U equals to 35, and let's get an equation for T. So we have X equals to 35 times T plus a half times A, which is 0.4 T squared. So X equals 35T plus 0.2 T squared. Then we can apply S equals ut plus half at squared for B. Okay, let's underline that for B. Now this time it's gone a bit further. It's gone 200 meters further than A did in the same time. And we've got, in this time we've got A equals 0.5 and U equals 44, and T is what we're trying to get an equation for. So we've got UT, so that's 44T plus a half times 0.5 T squared. So that gives me X plus 200 equals 44T plus 0.25 t squared. But so now we can substitute for x there. We can compare the two because one's 200 meters further than the other. So we've got 35t plus 0.2t squared plus 200 is equal to 44t plus 0.25 t squared. Okay, so let's take it all over to one side. We get 0.05 t squared. 35, the difference between 35 and 44 is 9, so that's plus 9t minus 200 equals 0. Now you can use your calculator or whatever at this point, but I'm going to resist. I'm going to times these by everything here just to times it out. Times it all by 20. We get t squared plus 180t minus 4000 equals to 0. So that factorizes t minus 20 and t plus 200. Obviously the negative solution is not appropriate. So you've got t equals 20. And now once we've got t is equal to 20, we want to just look at the speed of b. I think it asks for the speed of b as it overtakes a. So we now have a is 0.5, t is 20, u is 44, and we need to work out v. Just using v is equal to u plus at. So v is equal to 44 plus 0.5 times 20. So v is equal to 54 meters per second. Okay, so that's question. It's actually okay to do once you know what to do, but a lot of people struggle to actually get the equation set up. Got a couple of questions to go. I think we'll do that in part 3. Okay.